Welcome everyone to this video. We're going to start talking about how we can calculate and how we can find the amount of expansion work that has been done given some change in state. Okay. So we're going to start with just thinking of a piston. Okay. Right. It's a very simple system to kind of talk about when we're talking about expansion work. Right. You have some piston. Right. The top of this piston can move up and down inside the cylinder. Okay. Right. And when the height of that piston changes, right, it's going to correspond to some amount of work that's being done, right? So let's think of some very small change in the height of this piston, right? Small change in state, right, is going to be related, right, with some small change in the internal energy of our system, which is related to some small heat transfer, some small amount of work, okay? Right? Now remind ourselves when we talk about pressure, right, that pressure is force over some area. Will come in handy, right? So let's consider now work done by expanding against some sort of piston, right, fitted in a container, right? So, and that piston is being pressed upon by some amount of external pressure, okay? Right, the force required to move this piston up some height, okay, is going to be related with the pressure that's pushed on that piston times the area, right, of that piston, right? Because you have the pressure is pressing on all over that different area, and that's really the force that's being pressed against this piston, okay? All right, and so, all right, if we want to calculate the amount of work that's being done when we raise this piston, right, if we recall from physics, right, the amount of work that's being done is related with force that's being applied over a distance, right? From classical mechanics, right? Work is force over distance, right? So if I move this piston up some amount dz, right? Remember that this piston, right, is being pressed upon by some force, okay, in the opposite direction, right, due to the pressure, right, the external pressure that's being applied, okay? So that force that's pushing down on top of that piston is related with the external pressure on top of the piston, okay? And so those guys are moving in opposite directions, and so that's where this negative sign comes from, is the fact that as we move the piston upwards against this external pressure, right, we're pushing against some force that's being applied in the opposite direction. So that's where the negative sign comes from, right? But again, any amount of work done from some infinitesimal change in the height of this piston is related with, right, the force it's pressed against and then that change in height. Okay, so if we go back to, again, the idea of this piston, right, we're pressing against some external pressure, right? That force is related with the external pressure times the area in which that pressure is being applied over, okay, area here, okay, right? I can use the fact that area times this small change in height is related with some small change in volume, right? So it's related with dV. And so I can rewrite this in simplified form, right, where I can write that some small change in work is related with the external pressure and some small change in volume with a minus sign. So this equation here, dW equals minus P external dV, is true for all types of expansion work. Some infinitesimal change in height or volume is related with some small amount of work that's being done through negative times the external pressure. Okay, and so this is, again, it's a general result, and we'll use this result in future videos to describe how much work is being done when you expand against an external pressure, right, versus a reversible changing pressure. Okay.